Well, good morning. And I thank you for your interest in this topic, and I'm glad to see all four of our panelists are here to join in this discussion. It's been 2 years since I had suggested this topic to the organizers of CanMed, and a lot has really happened within this particular area during that time. There's been growing interest in the field of sustainability and how it needs to be adopted within this industry. So we have 60 minutes. I really do hope to have audience participation, so we will leave time for questions. First, I would like to move to introduce our panelists. I'll just do that briefly, and then they will introduce themselves. We're really lucky to have these four individuals here because they cover a big swath of the topics that can fall under the hidden costs of cannabis, which is actually really broad, covering environmental impacts as well as the interface between the environmental impacts and human health. So we have Professor William Vizuete from North Carolina, who has been fundamental in adding to our understanding of some of the biogenic volatile organic compounds that emanate from the canopy of cannabis grows, and his involvement in how to mitigate those compounds. And then we have Professor Ted Grantham from UC Berkeley, who has been studying water issues related to illicit cannabis grows within the state of California and just the increasing water demands for this industry. We have David Traylor, who is going to bring a unique aspect to the discussion. He's a biochemist turned venture capitalist, and he's been active in funding efforts within the cannabis space, and he will offer his perspective on the market dynamics. And then we have Professor Max Leung, who will be filling in on this interface between the environmental impacts of cannabis and human health. So the format that I've put together for today, and I just have a handful of slides really, more as condiments to the discussion because it's really what our panelists have to offer on these topics. But there really hasn't been any systematic studies that have documented the human environmental impact of cannabis until quite recently. There have been a couple of new publications, and the first bullet here has to do with a publication that came out of Colorado State University, which was the first attempt to actually quantitate the greenhouse gas emissions from cannabis grows. And you can see we have some really whopping numbers there, the equivalent of up to 3 million cars. Then we'll also be able to address the air pollution and odor, again, from the BVOCs. Water, waste, an emerging issue for this industry, and particularly here in California, is the single-use plastics that are so widespread within this industry. That and the additional waste of the throwaway of so much of the plant that's not used, including the roots. And then we'll look at this human health impact. So I would like to start by asking each of the panelists to, while introducing themselves and telling us how they got involved in the cannabis industry, but to add comment on these topics for the current state of the cannabis industry from their unique perspective. So whichever one of you would like to start the discussion.
Well, I'm David Traylor. Thanks everybody for being here. So sitting next to all these PhDs, I feel like that old Sesame Street song, which one of these doesn't belong with the other? But so as she mentioned, I have a science degrees, got into biotechnology. I have 15 years operational experience in biotech companies in Berlin, Boulder, Colorado, Silicon Valley. And then got on investment banking in 2005, and then I started my own firm in 2012 doing investment banking, and that's when Colorado and Washington went legal. So we started advising companies. So we're the first investment bank in the U.S. to advise cannabis companies. And then also, certainly, we've spoken actually around the world. We had our first Israeli client 6 years ago in January. So I've spoken on cannabis in Dubai, Davos, during the World Economic Forum, Frankfurt. We're sponsoring an event in Berlin this year, and then around the U.S. Thanks.
Hello, my name is Maxwell Leung. I'm a new assistant professor from Arizona State University. I'm very excited to be here. My background is also quite unique, compared to other PhD people. I actually am a state regulatory toxicologist, working with the California Department of Pesticide Regulation, and also in support of the regulation with the California Cannabis Program. So my main interest is in two areas. One area is the impact of environmental contaminants in medical use. So usually when people talk about environmental impact, they wouldn't think that, oh, okay, it may kill some animal down the street, it has nothing to do with me. Well, cannabis is a sequestering plant. That means that the environmental contaminants in the environment, including pesticide, toxic elements, and also microbial contaminant, it will be sequestered in the plant. It might actually affecting our use for medical purposes. Now, another area that I'm very interested in is the what I call positive uses of cannabis sativa for the environment. So now there's this cousin of cannabis, hemp, which contain very low level of THC. Now, right now we there's a lot of research on the environmental impact, but I'm more interested in the environmental application of, say, using hemp to remove contaminants from the environment, a process we call phytoremediation, and also potentially using hemp to capture CO2, something called a carbon offset, process that have under a lot of interest is biochar. So very excited to be here and talk to you all. Thank you.
Thanks. Good morning, everyone. So my name's Ted Grantham. I'm a professor in the Environmental Science Policy and Management Department at UC Berkeley. And about 5 years ago, I was involved in the establishment of a new research center at UC Berkeley called the Cannabis Research Center. And it basically brought together a group of faculty that were interested in different dimensions of cannabis research. And I think one of the sort of distinguishing aspects of our center is that we're focusing much more on the cultivation side and less on the sort of biomedical dimensions that are being addressed in this conference. But we saw a real need to get a better understanding of how cannabis is being cultivated in the state of California with the passage of Prop 64 to ensure that the policies that were being developed made sense, reflected reality on the ground, and we're going to be ultimately be successful. So we broadly at the center focus on the sort of environmental, social, and policy dimensions of cannabis, primarily focusing on California, though we do collaborate with others outside of the state. And as I mentioned, we really study cannabis as an agricultural commodity, rather than a federally restricted drug. And our team includes, economists, ecologists, anthropologists, legal scholars. I'm actually an ecologist and hydrologist by training, so definitely an outlier here, I think, but I'm really happy to be part of the conversation. I just want to quickly comment on some of our work around water in particular. When the state developed its regulations around cannabis cultivation, there was a lot of attention given to the use of water, potential environmental impacts associated with water resources. And there had been some studies, some sort of anecdotal evidence that cannabis water use was having a negative impact on some of the sensitive species we find in the state, like some of the salmon and other sensitive species, particularly in Northern California, which was the historical epicenter of cannabis cultivation in the state. And so for this reason, the state developed very stringent requirements intended to mitigate potential impacts of water use. But they really developed these policies without actually knowing very much about how water was actually being used. And so we saw a need to sort of fill this knowledge gap and address very, I think, fundamental questions, basic questions around cannabis water use. Where does cannabis source their water? How much water they're using, and what context? How does that vary by different cultivation types, for example? And of course, what are the environmental impacts? And so I'll just briefly mention some of the findings that we've sort of developed over the, realized over the last couple of years. First off, there's no evidence that cannabis is a particularly thirsty crop, despite some portrayals in the media. When you look at cannabis water use, per acre or whatever unit of area you want, it's really on par with many other conventional agricultural crops. We have found, however, that there is really substantial variation in water use by cultivators. In some cases, even orders of magnitude for a given size. And so there seems to be a lot of variation in water use practices that we don't yet fully understand. And this really points to, I think, a broader need, not just to water, but for really standardization and the establishment of best management practices, from everything from water to pesticide use and other aspects of cultivation that exist for pretty much every other crop in the state and beyond, but is not yet for California. Just two other comments. One, we found that when we look at cannabis water use relative to all agricultural use in the state, it's less than a fraction of 1%. So it's a tiny volume of water is being used for cannabis relative to all other crops. But I will say there is still concern about cannabis impacts in certain contexts. And this can include some of the places in Northern California, these smaller watersheds, where water is naturally quite limited. And these are the places where we might expect to see potential for impact. So it's really all about context. So I think in some cases we've seen sort of maybe an overestimation or portrayal of potential impacts, but in other cases there are real causes for concern that we'll continue to research. So I'll just maybe close by mentioning that we're also studying a host of other sort of environmental dimensions of cannabis, including wildlife and wildfire and greenhouse gas emissions and the nexus of these concerns with state policy and regulations. And so I encourage you to check out our research center and papers at our website, which is again crc.berkeley.edu. Thanks.
Wonderful. Good morning, everyone. Hey, I'm Will Vizuete. I'm a full professor of environmental engineering at University of North Carolina in Chapel Hill. I'm in the School of Public Health there, so we're a bunch of engineers and scientists interested in solving public health problems. And the public health problem I'm most interested in solving is air quality. So for the last 17 years or so, I've been studying the connection between exposure to air quality and its connection to human health. And one of the ways that we understand how air pollution is formed in the atmosphere is understanding the interaction of biogenic volatile organic compounds, so what you have called monoterpenes, sesquiterpenes, and isoprene. It's one of the biggest inputs from terrestrial vegetation into the atmosphere, and if we don't understand the emissions of those plants, we don't get a good sense of modeling for air pollution or our exposure. And that's what kind of brought me to this field. And so when I found out a decade or so ago that there was going to be legalization in a lot of these states, I was just curious, and I thought, well, I wonder what the emissions of volatile organic compounds are from these cultivation facilities, and is it in the magnitude in which that could rival other industries and have an impact on regional air quality? And when I looked up the emission factors for cannabis, there were none. It didn't exist, absolutely zero, because it's a federally illicit substance. The EPA, NOAA, NSF, all these federal agencies that would normally be providing that information, which you could look up for your car, you could look up for a gas station, did not exist at the time. And so I got some federal funding. I had to fly out of North Carolina, actually, and go to the National Center for Atmospheric Research in Colorado, where this stuff was legal. And I published the very first paper on emission factors, volatile compounds, the emissions of gases that come from these plants while they're growing. That spun off a few papers, and we also did a modeling study where we modeled the entire cannabis industry as a whole in Denver to see its impact on air quality in Colorado. Since that time, I've done other studies in Canada and California. I know it's been difficult, as my academic colleagues will probably attest to get federal funding to do any research in this area. And so I kind of abandoned it actually in my academic research, and I spun off a company, and that's what Bioscientific is. And so within Bioscientific, we use a lot of the same methodology and scientific knowledge that we have from studying the last 40 years. All these other plants, we've now applied it to the cannabis industry. And just some things that I found out that is actually quite fascinating is the cannabis plant is actually the most fascinating plant I've ever studied in my entire life, and several other scientists have tested that as well. When you study tomatoes or pine trees or these other things, you kind of get a profile of the emissions that they have. And what we found with the cannabis plant is that it varies widely by strain. Most folks probably already know that in this room. But it's really kind of unprecedented for other plants to have such a wide variety of different profiles of kinds of monoterpenes and amounts depending on both strain and life cycle of the plant. Which means that every facility that has its own unique number of strains and number of plants actually has its own unique profile of monoterpenes, sesquiterpenes that are being emitted out of that facility into the atmosphere. So that actually makes it very difficult to assess and regulate and come up with an inventory that's accurate for the cultivation of cannabis. The other thing that we found was that not just in the cultivation, i.e. in the vegetative and the flowering rooms, but also post-harvest is a significant source of emissions of these biogenic volatile organic compounds. The harvesting, especially if you're doing mechanical trimming, tends to create a lot of emissions of VOCs. And so if you're trying to assess an inventory of the total emission inventory into the atmosphere from cannabis facilities, you not only have to include cultivation, but you also have to include both drying, post-processing, harvesting, all those other activities to really get a sense of what the emissions are into the atmosphere. And I'll end on, there's been a lot of talk here about the benefits of monoterpenes, and they certainly are beneficial. There's nothing toxic that I've ever seen about breathing in monoterpenes or sesquiterpenes. What happens is when these monoterpenes and sesquiterpenes enter the atmosphere, they undergo oxidation, the same oxidation process actually that we just saw in the previous talk. Hydroxyl radicals in the atmosphere oxidize these things, and they turn into other things that are not nice. Formaldehyde, carbonyls, aldehydes, things that are not good for you. But they also produce ozone and particulate matter. And ozone and particulate matter specifically are the #1 killers of air pollution exposure in the atmosphere. And so it's not the actual VOCs themselves, but the process atmospheric chemistry that results in the ozone and PM that they produce. And that could happen both in an indoor environment as well as an outdoor environment. And that depends on a lot of other things that allows us, which is why we run these models to try to understand that. So, and lastly, I think we'll talk about odor. Odor is also a result of a gas phase molecule that's coming from these plants. And through our research at Bioscientific, we're able to identify the odor molecule that's causing that skunky odor. And the spoiler, it's not the terpenes.
Okay, thank you all for your initial comments. So, following this discussion, there are no existing guidelines specifically for cannabis grow facilities, but I know a lot of states, Colorado, California, are considering those. And I'm curious, what the panel thinks the timeline will be until we see guidelines published at the state level for either emissions, water effluent treatment or testing, and just general more oversight over the industry to monitor. And the issue with the volatiles, that you can smell them, but you can't see them. Whatever's going into the wastewater, we don't really know. It goes to the water treatment facility, and they're not set up to remove residual pesticides. And so I'm just curious what you collectively think the timeline will be before we see restrictions being imposed.
Well, that's a good question. One thing I wanted to mention, maybe it's a good thing for me to go back to, is kind of the history of cannabis and cultivation. I think I'm uniquely qualified to talk about that one, that I worked in bioprocessing, 2 leading biotech companies in Boulder. I have 2 patents in bioprocessing from the result. And if you look at cannabis, that's what cannabis is, right? This is a biological supply chain, right? Turns out I also was chief business officer at CERNA, which is one of the first public companies in the space. CERNA made climate control systems for indoor grow operations. And when you look at it, the history of cultivation in cannabis, it can definitely get much better. And to answer my thought on Cindy's question is, frankly, I don't think it's really going to be driven by regulations. It's going to be driven by economics, and it's going to be driven by people not being so stupid, frankly. I mean, you can look it up there. It was quoted in Bloomberg one time. There's been too much arrogance and too little humility in this industry. Case in point, there's a big LP out of Canada that just recently closed their large cultivation facility. Turns out it wasn't because of oversupply, it's because they sourced bad steel from China and it was flaking off into the product, right? We also recently talked to a group out of Cyprus that wants to use hydroponics to grow industrial hemp, which is probably one of the dumbest ideas you've ever heard. So I think what we believe is it's going to be really starting to be driven by economics. For example, you guys have probably heard, we have indoor grow ops. Those are going to probably start going away. You're going to be starting to do more outdoor grow ops. And then you're also seeing a lot of things being driven by what we call APT, or alternative production technologies, using E. coli, using yeast, using just chemistry, or even just doing outdoor grow ops. So we believe that this industry and the cultivation, the production of cannabinoids is really going to be driven by the economics of the market, and frankly, less so the regulation.
I also want to comment on the timeline for environmental regulation in general. I think there are 2 key factors here. One is federal legalization. So, for example, if I go to Whole Foods to buy a watermelon, okay, I wouldn't expect the watermelon to be loaded with pesticide and all the other contaminants, because all the food, like pharmaceutical, of course, but there are federal regulations that come to regulate and, most importantly, make the information available for what is the level of contaminants you would expect in that commodity. What do we need to test for that particular commodity? What are the risks that are associated with those exposure? With cannabis, that is non-existent at the federal level, because cannabis is still regulated as a Schedule I substance. And a lot of those regulations, because of that, is not in place. You don't have, US EPA, FDA, and all to regulate this, because they basically treat that as an illegal substance. Now, another aspect, I will agree with the other panelists here about the comment on the importance of the industry, to this, because you think about it, like right now, cannabis contaminant regulation is done on the basis of state-by-state regulation. So really, if different states, there's no, communication between them, there's no interaction with the industry across multiple states, this is not going to change unless we actually have federal legalization. So I think the interaction between the industry and also, different stakeholders at the state, the analytical chemistry is key to the timeline for environmental regulation.
I guess I'll just speak to the sort of California perspective and start with the recognition that, cannabis is subject to currently to the most stringent environmental requirements of any agricultural crop in the state, something that I'm sure many folks in this room are well aware of. And so while I think there is a need to establish standardized practices and guidelines to address environmental impacts, I think I don't think it actually would be very wise for the state to impose new restrictions on cannabis, particularly given the challenges that the state is already facing in bringing growers into the regulated market. One of the things that we've commented on and written extensively about are the fact that there are just substantial barriers to compliance for growers associated with these with the regulatory framework, and the environment is part of that. There are some issues with water where I think policy improvement might help lower those barriers to compliance, but there's been some discussion of those sort of market forces, but also issues related to local control in particular that I think are really getting in the way of a successful legal market. So I guess I'll just say, well, I think there is a need to standardize and develop guidelines to address potential environmental impacts. I think the best path forward in the short term would be through voluntary certificate programs, for example, that would encourage growers to use best practices and signal to consumers that best practices are being used rather than by taking a regulatory approach.
Yeah, great comments from my panelists here. So I'll speak specifically to two subjects. One is air quality, and the other is odor. Air quality is kind of a brighter picture. I mean, you're asking when regulations happen. It's happening now. Every time there goes a license comes up, they're asking for environmental assessments. Now, luckily, we have the tools and technologies and methods to assess air quality from this industry or any other industry. The issue with this industry is that we are missing those emission factors. If I was opening up a gas station, I could look up an emission factor for decreasing an engine. I could put it into existing regulatory models. I could see if that passes the regulatory permit or not. Everything exists for that for the cannabis industry except for the emission factors, which is what we've been trying to focus on for the past. So is it important to run those models, to do those systems, to understand where there's an air quality impact? Yes. Do those systems already exist? Yes. What's missing is just the data. And we would have that data if EPA was studying this stuff. Now, on the odor side, it's a little different. There aren't really any standards for odor right now, and so most folks, when they're trying to issue licenses, are saying we don't ever want to have an odor, right? And we're even further behind in that than we are on air quality as far as how to mitigate it, understanding what's even causing the odor, or in the inherent subjectivity of that odor. And so how we're trying to approach it in bioscientific is, now that we've identified the molecule that's causing that odor, we have engineered all our molecular capture systems to specifically go after the standards because we know what the molecule is. And so the hope is to have a zero impact odor as far as that. But these things are happening now, and until we get some federal legalization and some help from the federal government, it's going to be ad hoc, county by county, state by state, and it's going to be difficult, and it's going to create barriers to market.
Okay, thank you. And really sort of drilling down on this same topic on lack of federal oversight and a patchwork of state regulations, the focus has been turning to sustainability. In Colorado, the city of Denver has established a cannabis sustainability group, and they've actually published a document which is pretty impressive. And clearly, I think the industry is on a path to adopting more sustainability measures. But there are barriers to that, obviously. And we just talked about lack of regulations or need of regulations. But there's also the need for innovation and alternative technologies and maybe incentives. And maybe the incentives are economic largely, whether through the cost of additional imposed regulations or just through consumer demand for the industry to become more sustainable. Again, I bring up this issue of single-use plastics. It's huge, all these requirements for packaging for child-resistant containers. So I'd like to ask the panel their thoughts on how quickly or what are the barriers for sustainability for the cannabis industry.
Well, that's a good question. I think, again, it's probably going to be more driven by economics. And like, for example, I think one of the big questions that we see is what is cultivation going to be in the future and where is it going to be located, right? I mean, for example, we are in LA, right? And I'm from Colorado. and a lot of our water from Colorado goes to the LA aqueduct, right? So it's, right now we have, as we pointed out on the panel before, we haven't even really solved the water problem, and that's a big sustainability issue. But with that in mind, I think probably cultivation is going to move to places that are more amenable, like, for example, to us, there's two big questions: geography, and we look at this as a global perspective, right? So we've talked to operators that want to grow in the Canary Islands, and they want to grow in Jersey, the Jersey Islands, Greece, Lesotho in South Africa, Colombia, right? So where is that going to be? I mean, Colombia, everybody assumed that that was going to be, the solution to growing, because you can grow year-round, it's in the equator, but it turns out a lot of the public companies down there have got their clocks cleaned, right? So that's a big question. And then getting back to the alternative production technologies, there's a lot of companies. Demetrix, I believe, is a sponsor here. We're talking to a company actually in South Carolina that's generating APIs, active pharmaceutical ingredients, from a phytosource from actually cannabis. So the other question is, where's that going to go? And our belief is that the production of cannabis in the future, or cannabinoids, let's just put it that way, is going to be driven by the best way to make the highest quality molecules. Full stop. Whether that involves a phytosource or an alternative production technology or a combination thereof, we believe that's where it's headed.
I think the biggest challenge related to sustainability is that we need to start thinking about, the environmental impact of cannabis, from the environmental application of it. For instance, I talk about the potential of using hemp to remove contaminants from the environment. There's also opportunity to use it as a tool for carbon offset. So those research, because for both cannabis and hemp, both of them have just been legalized to grow in the U.S. So more focus on how do we actually use it, in addition to how does it cost the environment, right? Another element, farm waste. Also what do we do with farm waste? Well, we will figure out how to do it with deposit of biochar. That can turn out to be a process with capturing CO2. So thinking about the application side, as well as the impact side, is key. Another part I want to talk about is we need a better understanding with the biology of the crop. Now, for instance, if we're thinking about growing cannabis, in the U.S., a lot of the production is in the in-house. But if you're thinking about growing it outdoor, right now we don't have a strain of either cannabis or hemp that are selected specifically to grow in the U.S. climate. We do it clone by clone, but once you take it outside the control environment, where would we get productivity out of it? Very little information about it. In fact, this is actually one of my key research questions, because for me, if I'm wanting to use hemp to remove environmental pollutant, there's a lot of toxic element in Arizona. How do we even grow hemp? Where should we put it? Very little information is available right now, and one of the things that we do know is that we are not actually having the right biology. We don't have it out of this particular crop option yet for it to be grown widely in our state. So I think a better understanding of the biology of the crop is also key with its use with sustainability.
I guess I'll just offer the perspective that I think the potential for sustainability in the cannabis industry sort of relies entirely on the viability of the legal market. And of course, federal legalization is really the only, is the primary sort of obstacle, I think, to a viable market. But I think there's still a lot that the state can do to lower barriers to access, to help the system work more efficiently. I mean, there are certainly issues related to sort of financial barriers, the taxation that occurs from local state to state levels, from from cultivation to distribution, that can certainly be addressed. One of the things that we found in our research is that there seems to be sort of a geographic and scale transition in where and how cannabis is being grown in California, from away from sort of small scale production, again, primarily on the North Coast, but in other parts of the state as well, to larger scale production, predominantly in the Central Coast and areas a little bit closer to consumer centers. Now, this isn't necessarily a bad or a good thing, but I'll just say that, you know, one of the original intents of Prop 64 was to help transition these sort of historic or legacy grows into the legal market and sort of preserve the potential for small scale farming to be viable. And I think that's really critical when we think about the sustainability of the industry and the way that cannabis is being grown in the state. And there seems to be signs that we may be moving towards more sort of models of industrial agriculture for cannabis cultivation that has well-known negative environmental, social, economic impacts that I think should be concerned for anyone trying to move this industry towards a more sustainable practice. Thanks.
Great, yeah, it's great always being last on these panels, right? Now I got to think of something to say now. So, the thing about sustainability from my standpoint is focus on community air pollution, right? Their exposure. If you're a cultivation in a community, you want to be a good community neighbor, right? You don't want to be producing air pollution, right? Also community health, right? The workers that are working in these facilities and what they're exposed to, we're also interested in, but also energy usage, right? So if you're going to be filtrating out these chemicals that are being emitted by the plants, you want to be able to design a filtration system that takes out just enough and not too much, right? You don't want to over-design and you don't want to under-design. And so I'm trained as a chemical engineer, and I've always been taught that you need data to understand the problem. And so I think that's one of the barriers that we have to developing the solutions and technological as well as legal solutions for these problems is our lack of data, right? And so we're trying to address that in bioscientific, where we're looking at the gas phase emissions from these plants to understand exactly how much is being emitted by these plants, so then we can design systems that exactly breathe in what the plants are breathing out, no more and no less. Also have a sense of how much of molecules are coming out of the odor molecules. If you have those, and you can use models to see where things are going, to see where hotspots are occurring, and you can assess the efficacy of your controls. So I think in addition to what my panelists have said, I think having data, scientific data, is critical, and it's one of the big gaps in this industry.
Yes, thank you so much. One of the ways industries move forward is through innovation. And, I started this list 2 years ago for this panel. And of course, now LED lighting is so common. And it, in some states, lighting requirements are in place. I know in Colorado, a movement again to move away from the wastefulness of this industry, where the incorporation of living soil systems, where you're not throwing away your growing matrix every year, and it also saves on energy. Of course, I think there is a need for monitoring effluents that are coming out of grows. I mean, we have really no idea about the concentration of certain chemicals that are widely used within these large-scale grows. Of course, Professor Vizuete has already talked to us about volatiles and odor mitigation, but I think that's becoming way more standardized. And as we're going down this list, it's more recent innovations. One of the things I recently learned about is recycling of CO2. So there's a company in Austin, Texas, I can't remember their name, of course, but they came up with this idea of capturing CO2 from local breweries and compressing it, and then making it available to cannabis grow facilities that normally do use CO2. And that's happening now in Colorado as well. And it's just like, well, what a great, simple idea. And then for me, the most interesting new concept I learned about is called cold plasma fertilization. So plasma is like what exists on the surface of the sun. And sometimes it's referred to as a fourth state of matter, but it has been shown to be able to deposit nitrogen locally just where it's needed in a cropping system, rather than flooding your plants with excessive amounts of nutrients that again end up in the effluent. So I'm curious if the panel members have heard of any innovative trends on the horizon for this industry, and how it might help preserve the longevity of indoor growing of cannabis.
Well, yeah, indoor and maybe even outdoor. Well, a couple of interesting things just we've heard recently. We have hopefully a client we're going to sign up this week that looking at LED lighting. They essentially did a study right before the pandemic hit in Brazil where they were actually supplementing outdoor cultivation with cannabis and some other plants using LED, and saw actually increasing yield by supplementing the natural ambient light with LED lighting, which I thought was pretty cool. And then there's another company we just talked to out of Colorado that is generating terpenes. So again, I think I mentioned this, our belief is this, and especially you folks that believe in the entourage effect are going to hate me, but we believe this is all going towards molecules, right? And so, and if you saw Dr. Smellman's talk yesterday about emergent behavior and complexity, we need to be smarter about deconstructing what molecules do what, which cannabinoids are valuable for which indications, right? And so getting to this company in Colorado, they're using hop sources, effluent from breweries, to generate terpenes, which is pretty cool, right? And so that's a cheap way to do it, much cheaper than indoor grow operations. So, and then for example, I don't know if you've heard about the company right now that's growing hemp outdoors. They're concentrating it down to a CBD extract, and then they're doing a common chemical conversion from CBD to THC, delta-9 THC. So they're not even doing this under regulations. So again, it gets to the point where technology is, I believe, going to drive where this industry goes.
I don't have a lot to offer regarding like indoor farming, but I do want to speak specifically on the farm waste management, of the cannabis production. So growing cannabis produces a lot of farms where you harvest the part that is useful, and then the other part you have to find a way to deal with it. They do contain, some of them do contain THC. So it's the usual practice is you just send it to a disposal site. But there are different uses for different parts of cannabis as a crop. One way to do it is, okay, let's just see if we can make dual purpose crop. You can get the THC component out, and then you can also get fiber. So that's one way to do it. Now, another way to do it is that you can actually use cannabis as a crop, in farm waste management for CO2 capture. The idea is that if you think about the crop, most of that, the ones that are not useful are cellulose, right? So it's not really a very good, chemical composition for carbon capturing. But one way that you can deal with it is that now in Arizona, we have a lot of sun. Okay, so you have farm waste, and then one possibility is you can leverage the solar energy that we have to convert the farm waste into biochar. Now biochar is charcoal, right? So you basically make all the component not bioavailable. So not only that you remove the THC, but you also remove the capture the carbon along the way. So that's the only thing I can offer with indoor farming. Yeah.
Yeah, I don't have much to offer here either. I'll just mention, briefly on water use in particular. I mean, I think there are certainly a lot of innovation happening in the water space around efficient irrigation, but I think it really points sort of back to an earlier topic around the question of sort of setting standards and the absence of standards around certainly irrigation requirements, but also other cultivation practices. And without a benchmark, it's difficult to I think create incentives for implementing the types of innovative technologies that are coming online.
Yeah, so some of the things that I'm looking around and some of the work that we're doing actually, since we are able to completely fingerprint every single strain that we come across, we've been toying with the idea of using that as a marker, right, to identify whether you really have the strain that you think you have, or also to check your clones, right, to make sure you have the right clones before you have to wait till they're fully grown. So using the gas phase emission as a fingerprint is an interesting thing. The other thing that we've been looking at that's been pretty novel and very recent actually is this odor issue. So we have identified a thiol molecule that does that, but it's not just the amount of thiol, it's actually its interaction with the monoterpenes that leads to odor, and it's a really interesting dynamic that we're trying to study there. And then lastly, a lot is going toward having kind of a clean environment for both your workers as well as for the cultivation of your plants. So in addition to our molecular filtration, as well as our waterless vapor phase capture, we're also doing closed ionization for electrostatic capture and deactivation of viruses and molds and spores, in addition to capturing a lot of particulate matter all the way down to the ultra-fine size, so these nano-sized particles. So that combined with charcoal filtration and the vapor phase really attacks all the different things our folks and your plants could be exposed to. So it's pretty exciting. And again, all this wouldn't have been possible without understanding from a molecular level what's going on and being emitted from these plants. It's amazing what you can do with just a little bit of data.
Great comments. So in spite of all of these innovations and optimistic outlook, we still have significant challenges ahead, and I didn't list on here, but I should have. Number one is the disconnect at the federal level. If we didn't have these arbitrary geographic boundaries between states, I think that would solve a lot of the issues, mainly that cannabis could be grown outdoors where it's could be grown at a cheaper cost, and certainly places like Las Vegas that have a horrible shortage and scarcity of water from the Colorado River is not a good place to be growing cannabis. But I just will highlight some of these. I keep harping on the single-use plastic waste. Water scarcity, which is going to be an increasing issue for all of us across the globe. The increasing costs, running any cannabis operation is incredibly expensive. Testing costs, licensing, all the waste that's occurring. All parts of this plant could be utilized instead of ground up and mixed with concrete and hauled to the dump. Obviously, there hasn't been a detailed study addressing the exposure of cannabis workers who are inside these facilities. I know it's been mentioned a little here by the panel. Of course, on the health and medical side, we know so little about dosing and how these various phytoactive chemicals are interacting together. And we have a growing industry, which is the production of specific cannabinoids in vitro. They're being fermented in yeast, and I tried to get someone from one of those companies on the panel because I think we'll start seeing an impact from that, particularly as this industry matures and there's more pharmaceutical companies that become interested where they want to have very defined amounts of different cannabinoids or specific cannabinoid. It'll be much easier to just acquire it from one of these companies because you don't have to worry about the presence of any residual cannabinoid. Like currently, you can't really say that something is THC-free if it's made from cannabis because there's no safe harbor quantitative level. So I think it all comes down to, in the final go-round for our panelists who've been great, is how sustainable is indoor-grown cannabis?
Well, to me, it gets down to two things: direct economic impact and doing the right thing. For example, as you guys probably heard, in December 30th, we had that terrible fire in Boulder. My daughter goes to school up there. I went to school there. And having that happen, and I was born and raised in Colorado, to have that happen December 30th and a fire like that is just absolutely mind-blowing. That fire was so hot, they're having to rewire the cables that were buried 3 feet below the ground because it got so damn hot. So when that stuff starts happening, and I think you guys would agree, global climate change is going to get addressed when people start getting direct economic impact, like their land in Florida starts going underwater, and people start doing something about it, right? And for example, like getting back, we've talked to a group out of Mongolia, right, that's growing hemp. And, it's going back to its roots, right? Can you imagine there's probably not many better places to grow cannabis than Mongolia with economics, everything else. One last thing I want to just really quickly add, doing the right thing. I think you guys would agree that if you're in the cannabis industry, for example, my daughter or my wife's family are big oil people. And you can't tell me that there's not a difference in culture between cannabis and oil. Most people I know, having been in cannabis as long as I have, are interested in the environment and doing the right thing. So I think that's critical.
I want to speak on it from the perspective of urban farming. So one of the projects that I have done, at Arizona State University is to look at the location of the cannabis and hemp farm, in Arizona. And one of the things that I found is that when you're building like a greenhouse, and of course, like the growing environment in Arizona very different from California. So I ended up seeing a lot of big indoor farm that are located right in the middle of the city. So they actually go right along the highway, which is really interesting because I know you guys are working on geospatial analysis too, and you have the satellite imaging analysis. We found out that the best way to pick those out in Arizona is not the farm. It's the air conditioner on top of the building. So one thing that I want to, it's quite amusing actually what we found, but one thing that I want to speak on is that when we talk about urban farming, you talk about greenhouse, you talk about hydroponic, but how about in urban farming outdoor? All right, so kind of go back to the biology. Okay, if you put a cannabis sativa in the field and in Arizona climate, would it actually grow? If not, what kind of selective breeding do we need? Would it actually be a viable solution? Let's say I have colleagues in the U of A extension that are working on leafy green of hemp, right? That can be an option for urban farming. Alternatively, if that doesn't work, then we also, can use hemp, again, for phytoremediation, pull some of the pollutant out, then you can grow other things in. So, I guess that's one area that, should, that I would be very interested to research in more. Yeah.
Yeah, I guess I'll just sort of revisit a point I made earlier that I think that the sustainability of the cannabis industry really depends on our ability to create viable paths for small-scale outdoor growers to exist and thrive in the legal market, and there are obviously major market forces that make that path difficult. But there are also a lot of, I think, regulatory and policy changes that could be made to reduce barriers and to support that particular segment of the cultivation matrix. The question of indoor cannabis and whether it's sustainable. I mean, it really depends on how you define sustainability. When you look at the energy intensity, I will say there haven't been any great studies that have, to my knowledge, that have done sort of a fair apples to apples comparison of indoor to outdoor in a California context, at least. But it's hard to justify or investing in really large scale indoor cultivation in a place like California where outdoor cultivation is such an obvious alternative, given especially the state's goals for greenhouse gas reduction. And that may be an unpopular sentiment, but happy to speak with you all after about that topic too.
Yeah, all interesting things, and the answer to this question, it depends, right? It depends how you define sustainability. It depends on how you operate these facilities. I've visited, probably dozens of different kinds of facilities in at least 3 or 4 different states, and it's amazing how different everyone does this. HVAC systems are completely different, filtration's different, humidity's different, soils they use is different, and all those different variables affect energy uses, affect relative humidity, affect temperature, affect all these other variables that go into this. And I think I'm right, there's not enough data available to say how do these things compare to other activities when it comes to energy, pesticide use, and et cetera. I can say from an air pollution standpoint, if we're talking about sustainability, indoor grows are probably easier to control because it's an indoor enclosed environment. You can much easier be able to capture any molecules that are leaving the facility in an indoor environment. Now, whether that's better from the other standpoints of sustainability, that's a different question, right? Is it easier to control air pollution in indoor grow than outdoor grow? The answer to that is indoor grow is easier. Now, can you do it in an outdoor grow? Yes, absolutely. We have lots of different kinds of technologies that allow us to do that. So that's a possibility as well. So I think when it comes down to sustainability, it's going to come down to energy usage and water usage, I think, are the 2 things that folks should be looking at.
Okay, great comments. So we have a few minutes left. If anybody out there has a question for any of our panelists, this would be an opportune time.
I know I saw folks standing earlier. Now's your time.
Hi, good afternoon. Almost afternoon. My name's Cameron, and I am a legacy cultivator, and I have the very first permitted cannabis farm in Sonoma County. We grow using permaculture and regenerative farming practices in the soil, and I find myself spending more and more time at Board of Supervisors meetings, especially over the last 5 years, having to go up against, we have large NIMBY, not in my backyard groups, and they are really driving policy, specifically in Sonoma County. And we have people showing up to every meeting talking about, one, water usage, which thank you for putting that paper out. We quote you all the time at Board of Supervisors meetings. But one of the big comments is we have people saying that the terpenes from our cannabis is making them sick. And we're allowed to grow 10,000 square feet, and we're outdoors. And I would like to be able to know what does the science say about the terpenes making neighbors a mile down the road sick?
Yeah, it's a great question. So, and that's something I've looked into quite a bit. So there have been studies looking at worker exposure to monoterpenes. One of the largest exposures to monoterpenes is pine workers, or pine sawing pine in North Carolina. They see parts per million, so orders of magnitude higher concentrations of alpha pinene 8 hours a day, every day, for decades. They followed those workers, looked at all their public health stuff for those workers, and found out a single toxicological effect from being exposed to alpha pinene at levels that are orders of magnitude higher than what you would find in the ambient environment, at exposure times that are 8 hours a day, right? And so the terpenes themselves have absolutely no toxic effect on humans. We've evolved with these terpenes. We love the smell of alpha pinene and that pine smell. We've evolved as human beings to like those. The issue with the terpenes is that when they react in the atmosphere with a source of combustion, like a car or NOx sources, in sunlight, they react and form ozone and they form particulate matter, and those things are not good. Now, does it always form that? No. In fact, it's very complicated, which is why we run these air quality monitors. And just to give you a quick example, if I put something in downtown Denver, which is high desert and low VOCs, that could impact ozone. But if I put it in Carpinteria, where there's an ocean of biogenic VOCs already there, adding a cannabis facility has absolutely negligible impact. You can tell folks in California, you're being exposed to those terpenes every day. When you peel an orange, you get more exposure to those VOCs than you do anywhere else. Hope that helps. And I could talk to you after, too.
Thanks. Cameron actually asked the question that I was going to ask as well. But I am from Massachusetts, and I think the question was presented at the beginning of the panel. Do any states have regulations on energy usage? Massachusetts does. They address the light power density of a cultivation, which we have to deal with and abide by to some extent. So they're trying to, in some ways, pressure people to be more sustainable, at least with respect to lighting, if not HVAC. But part of the problem there is they've also released outdoor licenses. Our company has a greenhouse as well as an outdoor grow license. and the microbe thresholds is the problem there. So the experts that were talking about how much energy usage we should be having did not speak with the experts who were talking about microbes. So total yeast and mold count, they talk about 3 bacteria in particular, and then total yeast and mold is so prohibitive that you can't possibly grow outdoors and sell that flower without radiating it or doing something else. So it's an interesting model that I would encourage you to check out. Come take a visit with me if you'd like and see what we're dealing with. But that's what I'm saying.
I couldn't hear it.
I couldn't answer the question there.
Energy usage, I thought it was.
Well, so was there, the question mainly was what the regulations on energy are, right? On energy usage. Yeah. Yeah, well, real quick, from my perspective, in Colorado, the energy usage went way up, and then, a lot of these things are going out of business, et cetera, so there's a big bump. And I know Excel was starting to give rebates. There was also a lawsuit in, I think it was Colorado Springs, where somebody sued Grow Op because of smell, and I think the plaintiffs, the people that got the smell, ended up losing that lawsuit. I don't know, anybody else?
Yeah, I mean, odor is a real issue. People, I mean, I hear from communities all the time about the odor issue, and I'm telling you, we don't know a lot about it and a lot how to mitigate it. I mean, prior to us discovering that molecule, everybody, if you talk to most of the industry, they thought monoterpenes were causing the skunky odor. And there's even companies out there who monitor monoterpenes to make sure your odor is okay. And what we've seen is you can have an anti-correlation because that's not the molecule that's driving the odor. And so both in the science and understanding that what's driving the odor, but also on the subjectivity side, everybody has a subjective way to do odor. And these nasal rangers, forget about it. There's no precision in that whatsoever. The only precision you can get for odor is using a odor panel, which is a much different thing. So it's a wild west out there when it comes to odor, and we're trying to bring some data into the equation.
I just have a really quick comment to the gentleman from Massachusetts. Now, of course, growing cannabis in Arizona is very different from Massachusetts. I can tell you from one of my project, I actually looked into hemp growth in the Yuma County in Arizona, and it's really hot there. And I want to say when it gets hot and you're growing hemp outside, it smells really bad. And it is so bad that the farmer in Yuma County, they have to kind of like hide from their labor because you drive past the highway, you just got this block of, smell. And then you just look at your labor, oh my God, I'm growing hemp in my farm. So I can totally agree with what you just said.
Now, what's interesting with that is, and we'll let the next person question is when it's hotter, it's probably not because there's more of those sulfur molecules. It could be that there's more dilution and more reactivity of the terpenes. Oh. So the terpenes go away, revealing the thiol, right? If you've been in a cannabis facility and you go inside, most of you probably don't smell that skunky smell. You open a door and you go 5 feet away, all of a sudden it hits you like a wall. It's because of the ratio of those emissions. So it's really a fascinating subject.
Okay, your question, ma'am?
Yes, hi, and it's Miss. we don't use ma'am anymore.
Okay, I'm having a really hard time hearing.
Is that better?
Yes.
It's
yes.
okay. That was a little bit of a joke. Firstly, my name is Sharon. I'd like to thank the panel. This has been a very interesting topic because sustainability of our planet is really the #1 key topic that all humans need to address if we're going to stay here, all right, or end up on Mars. I would like to address the aromatic principles that the last gentleman had brought up with regard to odor and odor abatement. The terpene the terpenes, when they are isolated or alone and you smell them, they're not really that exceptional. So linalool, which is the predominant terpene in lavender, you extract that and it doesn't smell anything like lavender. Lavender has over 625 plus metabolites in it. And that's what makes that aromatic blend. So cannabis is related, it's as an herb, has its odor profile. There are two classes of chemicals. You did mention the thiols, the mercaptans, and the pyrazines. There's not much that's mentioned about the pyrazines. And that is something that is quite problematic to a lot of humans, that causes a headache and causes fear.
Excuse me, ma'am?
Yes.
We're actually going over on time, so do you have a question?
My question is actually to address that in terms of the odor abatement and what you found to be significant to capture the byproducts after they're emitted into the air.
Right, so we rely a lot on molecular filtration for that. So we are able to analyze the gas molecules that come off the plant and identify mostly thiols, a group of thiols and other sulfur-containing compounds. We then are able to synthesize or buy a standard of that specific molecule and then engineer our controls to capture that. So we have a real good efficiency of capturing these sulfur molecules. You know, the problem with the odor is that nobody's going to give us a part per billion odor detection threshold for any of these sulfur compounds. There isn't one that exists. And so currently we're trying to engineer to capture every single sulfur compound. So if it has a sulfur compound, we're able to capture it and make sure it doesn't leave the facility. And that includes all the sulfur compounds, even the ones that may have tag. Now, I don't know about the pyrazine molecule. I'll have to go back and check to see if that's actually emitted by that. I don't remember seeing that on the list, but I can check on that.
Okay, thank you. So we are actually out of time. In fact, we've gone over our time allotment. If you have other questions, you could come up here. But before you go, please help me thank our panelists who've provided us with such an interesting topic.